As of yesterday morning, I'd ridden my bike 392 miles commuting to work. I'd put another 40 miles on since then. And almost the first thing I do when I get in the office is I download my recent ride from Garmin and put it up here. And no one can see my screen, so they can't see what silliness I'm engaged in for the first 15 minutes of work. But in December of... That's right. Yeah. In December of 2017, I quit Microsoft and I joined KenSci. And it was problematic in one way, in that I had started out in Microsoft, living in Seattle, commuting across the lake, working in Redmond, and then going back to Seattle. In 2009, I moved to Germany, and I spent 5 years living in Munich, where I was the services controller for Microsoft International. Upon returning to the US, my wife said to me, Jeff, we're not going to live in Seattle, we're going to live on the east side of the lake, close to Microsoft, so you don't have to commute across the lake anymore. 3 years later, I quit Microsoft and went to KenSci, and I just couldn't stand riding on the bus. It made me crazy. So I started out riding across the bridge. I get on the light rail and take the light rail into downtown, and so that was maybe 4 miles. And then my ride home was from, if you've ever been to Broadway, there's Dick's Hamburgers. So I'd get off at Dick's, and I'd ride from Dick's back, and that was about 7 miles. And my appetite for riding has dramatically increased. So now I'm aiming to be 5,000 miles this year in 2019. And so I'm on this Reddit forum called Bike Community. I don't write anything, but I read. And every once in a while, stories pop up about people who have started riding and they've lost 100 pounds and totally changed their life around as a result of bike riding. And I don't think it's quite that dramatic for me, but it parallels the way I think Power BI has affected my life. And so I thought I would break this presentation up into 3 parts. The first part being just the story of how I got started with Power BI and where it's led me. Second is an introduction to KenSci. And then third would be a demo of some of the things we're doing at KenSci using Power BI. Does that sound like it's all right too? Mm-hmm. Okay. So I finished business school in 2000. My fiance and I moved out to Seattle, and I began work as a controller. And it was kind of funny because I really didn't know accounting at all. And so I was pretty confused by it. But I persisted in it. So I kept with it for about 7 years. I had 2 years in Singapore managing the Asia customer service and support finance team. So every quarter I went to Bangalore, Shanghai, Tokyo, Sydney, and then back home to Singapore. It was a fantastic job. I returned to Microsoft, worked in EPG, the Enterprise Productivity Group, as a finance guy, and got kind of bored. And so I quit Microsoft, and I moved down to my family's vineyard in Yamhill, just outside of Yamhill. So that's my 2-year-old son, and from the time we moved down there, he was working in the vineyard. So you can see this is harvest. He's eating right here, but he was picking at one point. So we lived there for 2.5 years, and I learned a lot about winemaking. I also learned I was not going to get rich at all in the wine business, which is why I went back to Microsoft and then went to Munich. So in Munich, I had essentially the same job. It went from EMEA to MSI, but essentially the same job as services controller. And by the 4th year, I could do the job pretty much in my sleep. And I began seeing reports coming out of finance that were using Power Pivot. And I had really no idea what Power Pivot was. But I began to investigate it because I wanted to understand how these reports worked. And so let me reiterate the fact I'm a finance guy who doesn't even understand accounting. So for me, trying to understand how to build tabular models was really difficult. And I remember in Power Pivot, trying to drag the line from one table to another and have it being rejected because I didn't understand the one-too-many concept. And there was no one there to teach me. It was just me upstairs in my attic in my house in Munich trying to figure this out. But it hurt so goddamn much that when I finally learned it, I really knew it. And my methodology was this. I would take big pivot tables, say for services sales, and from those I would extract dimensions just in Excel. So I'd build my dimension tables in Excel and then join them to different fact tables. And the end result of all this work was a table where I was looking at the productivity of sellers across time that allowed us to understand that services sellers hit an inflection point in terms of productivity around 2.5 years. So the question then became, what programs could we put in place in order to keep sellers there longer and have them hit this inflection point? Which then led to the second and more valuable question was, how do we change that inflection point from 2.5 years to 18 months or 12 months? And for me, it was so powerful. It gave me so much power to be able to join these different data sources together and direct changes to this business, to help drive change in this business. And that for me was the real launch of becoming a true analyst. So then I moved back to Redmond and I began supporting this newly hired vice president of sales for the service business. And this guy was a sales guy, which meant he was just dumb as a rock, right? So in Munich, I know for 6 months that I was going to be going back and he was going to be my business partner. And so I had these dreams, these fantasies of us driving the business through BI. Like we'd sit together and we'd do analytics together and we'd find changes and we'd drive. He didn't give a rat's ass, right? He wanted 3 bullet points and a map. That's really what he wanted. And I had the hardest time showing him my value until one time we were sitting in a business review, and the Microsoft leadership team in the service business, they'd all been there 15 years and they were super analytical and they knew the numbers of the business. So they'd be writing off numbers and Arthur was trying to compete. And so Arthur would say, well, we were down 3% in Munich, in Germany this year. And they'd say, no, as a matter of fact, you were up 6%. And he just got his ass handed to him in meeting after meeting after meeting. So I set him up with a dashboard where I had a number of preset questions in Q&A where I could say, what was year-over-year growth in Germany? And he could change Germany to France. I taught him to do that much, and he'd get the answer right there in front of him. But all of a sudden, the guy became much more literate in these business meetings. And then he really saw the true value of analytics. And again, for me, this was really enlightening. So then, my first boss at Microsoft, you may know the guy, Mark Regera. He was my first manager at Microsoft in 2000, and I was his first employee. So do you guys know Mark?
I love his LinkedIn posts. I literally follow him to the T.
So Mark is the guy who runs the Power BI Cat team right now, and he was the finance evangelist within Microsoft. So he was the guy trying to get everyone in finance at Microsoft to use Power View and then Power BI. He was my first manager, and he was a horrible first manager. But that's okay, because I was a horrible first employee, so we ended up getting along really well. When I started using Power View, he saw some of my work. He said, Jeff, come and present with me at the EBC, the Executive Briefing Center. So I went down, and the first customer that I presented to was Audi Bank from Lebanon. And we were presenting to the CTO and his team, and Mark did most of it, but I had 2 little demos. And at the end, the CTO said to Mark, hey, Mark, do you want to come to Beirut and spend some time working with my team? And Mark said, no. But I said, I'll go. So 3 weeks later, I landed in Beirut, and I spent a week with them working on a project they'd been on for 4 months. And using Power View and Power Query, we were able to put together a product that they'd been trying and failing to do in 3 months. And for me, again, it was just another huge catalyst. So I began presenting more and more and more at the EBC. By the end, I'd done more than 500 customer presentations and was voted one of the top 5 speakers at the EBC. So this was the journey that Power BI let me on. I met Samir Manjure, who's the CEO of KenSci. He'd come to one of my EBCs, and he invited me to come down and present to KenSci. And I had no idea who he was, so I just blew him off. And finally, he got me on the phone one day and said, Jeff, I'll send a limo to pick you up at your office and bring you down and then bring you home. Just come down. So I went down, and just like I don't know anything about accounting, I knew even less about healthcare. But what I saw there was really intriguing to me, because it was, I think of it as 3 primary working groups. The first of those are clinicians. So these are doctors and nurses. The second are data scientists, people who are doing the machine learning experiments. The third are the engineers, the platform guys. And the degree of collaboration which is required in order for KenSci to be successful, I'd never seen anywhere else. And I was really fascinated by how interdependent these 3 skill sets were, and how what they could produce could be really powerful. And then the opportunity they ended up offering me was, how can we layer on our analytics to make all this very complicated work very simple for our users? So if you think, in many cases, we're trying to appeal to a nurse or a staffing nurse in a hospital who's trying to figure out how many nurses does she need to have on staff in order to meet demand, or how many patients does she have to get through to find the high-risk patients, and how can she do that very, very easily? So it forces me to collaborate with these different technical groups, but also forces me to think at a very deep level about what is my product going to be used for. And we're constantly reminded by the doctors and nurses on our staff that we're dealing with real lives. And our decisions can change lives, and our mistakes can ruin lives. And so it's something that we take very, very seriously. So at any rate, that's the story of how Power BI has really transformed me. I'm now VP of Analytics, which means I'm part of the engineering team, and I have to function as an engineer, and happily, I'm not quite as bad an engineer as I was an accountant. But for me, to learn the discipline of engineering has really been another great learning point, because engineers do think differently than, say, finance people. And to understand JIRA and Agile, I don't even, Agile, what, engineering, has been another evolution for me. But finally, I'm now able to sit at the table with guys who are true engineers and participate in helping to shape the product. And so again, Power BI has really brought me to a different place. So now let me show you a little bit about KenSci. Before I do that, any questions? Okay, well, thank you for letting me indulge myself with that storytelling. All right, so we think of what we do at KenSci as applied AI, applied machine learning to drive, improve operations, understand variations, and improve utilization across hospitals. So we want hospital systems to engage us to help them solve their really big problems. And those problems could be understanding how long they should keep a patient in the hospital, when they should release them, and then what's the risk of readmission once that patient has been let out. Another problem might be in an emergency department, which is what you say instead of emergency room. It took me about 6 months to get that one. But in the ED, how many patients are going to be coming in over the next 4 hours, and how do we staff appropriately to meet those needs? Another problem is in Singapore, I'll tell you more, but we have a fantastic program to track diabetes progression and help to retard diabetes progression for the whole country. So we're trying to tackle some really sizable problems. We think about working within 3 different systems. So the first is the systems of record. So we'll take data from health, from EHRs, or from claims primarily, in order to run analytics. We also can look at things like cost data or ops data. We do a great deal of work in terms of ETL, data ingestion, data shaping, and then we output in a variety of ways. So Power BI output is one of them. The most important one, the one we're working hardest on, is to try and integrate AI results back into systems of record or systems of use, so that people don't have to go to a different screen, a third screen, a second screen, in order to use our work. How can we integrate it right back into the Epic or Cerner screens that they're looking at right now? And as with any well-entrenched system, those companies are fairly resistant to letting us in, at least very easily. But that's what we're trying to do, is trying to boil down the essence of billions of rows of data into just a few columns that people need in order to make decisions. So we have really tried to reduce our areas of focus. We started with very grand visions, and we still want it to cover a lot of broad topics, but right now we're down to 3 basic solutions. So the first of these is patient flow. How do patients move through a hospital system? The second is utilization and cost. So this could be within an affordable care organization where you're trying to manage a population against a fixed revenue. How do you reduce costs, say, for high ED utilizers? Or how do you use drugs more efficiently? One example of that is IV provided drugs cost much more than orally consumed drugs. So we will go in and identify opportunities to switch from one drug package to another drug package. And then the third is population health and disease management, coming back to the Singapore experiment that I just referenced. Any questions? Okay. So we think about moving with a customer through 3 phases. The first of these phases we're calling variation analysis, which is really just descriptive analysis. So this is a place where my team plays a really important role, and that is getting a dump of data from a customer, running Power BI on it, just to look at what has happened and what's going on currently. And as with many customers that you're probably working with, their level of data fluency is oftentimes very, very low. So even the most simple type of analytics can really be revelatory for them. They can learn a ton from it. And what we can turn around in say 2 weeks often goes a long way towards interesting the customer in exploring further with us concepts that may be even more foreign to them, such as machine learning. And if you think about how many times you see fax machines still in operation in doctor's office or dentist's office, that's an indication of how technologically backwards many, many hospital systems are. And what a long way we have to go in terms of patient education sorry, customer education in order to bring them on this journey. But what we want to do is start out with a single solution. So one common solution is length of stay, being able to predict the length of stay of a patient and let people plan when they should release that. And that's paired with the risk of readmission. And it's kind of easy to understand, right? If you let a patient out before they're ready to go out, then the likelihood that they'll get sick again and have to come back in is higher. Similarly, or conversely, the longer you keep someone in the hospital, the higher likelihood there is that they acquire some type of infection right in the hospital, sepsis being a big one. So timing this and getting it right can save millions of dollars for customers, as well as get much better outcomes for those patients. So we want to have one solution. Yes?
I was looking at your last bullet point there, and I was trying to understand it. Are we talking about Power BI models? It says enable customers to build and extend on KenSci's model bank.
No, these are not Power BI models. These are our machine learning models, and I'll show you more what those are. But essentially, towards the first part is we will provide one solution, so length of stay, risk of readmission. We will run it using our data scientists, our data, et cetera, introduce it to the customer, get them fluent in using whatever tool we provide. But then the next step is we want then to provide them with an ML platform where we can train their data scientists to do their own predictions. And we can provide them with the models to do that. And what we're working towards now is not only that, but providing them with a whole ML team. So sourcing people to become FTEs on the customer site, providing all the training necessary, everything from Power BI all the way up to ML. And yeah, so that's the final. The ROI expansion will be bringing in more solutions, but also enabling the customer to start doing their own. And the hope is that the platform makes it sticky to KenSci. And so this is a pretty common schematic here. We ingest data from a number of different sources. All of this is Azure-based. For the most part, we're using the customer's Azure tenant because it's the easiest way to get KenSci in, is to say, we're not going to take your data away from you, we will stay inside your environment. That's been tricky to some degree because what that means is for every KenSci employee who we want to work inside of that environment, we need to go through an approval process. And that means that there's a lot of stickiness, meaning sometimes we may want to substitute one person for another person, one data scientist for another, and we don't have permission for it. So then there's a work blockage. So we're trying to get the ISO certifications necessary for our own Azure environment to be able to say to customers, listen, we have the safest environment. We know how to operate very, very safely within this environment. These are the certifications that we have. Bring your data to us. And then that gives us much more fluidity in terms of assigning people to go work inside of that environment. Okay, so I just have 3 client stories, and I'm going to move into demos. So Kaiser Permanente, you guys may know, is one of the biggest, most successful systems in the US. We worked with them on 3 fronts. So one of them that I'm going to talk about here is CHF, so congestive heart failure. Kaiser is organized into different regions, so this is working with the Southern California region. And we've implemented a solution which helps them to understand the risk, primarily the risk of readmission for current CHF patients. So this is not looking at a population and saying who's going to develop heart disease. It's for those with heart disease, how can we identify those patients who are at highest risk of having to come back in? And it leads to some pretty interesting type of analytics. So one of those is, 2 of the most important predictions we work on are visit compliance or non-compliance and medication consumption compliance or non-compliance. Because those are often 2 of the biggest drivers about why people don't come in, right? So if you miss a checkup where you might catch something, maybe they'll do something proactive to prevent an emergency readmission. Similarly, if people aren't taking their medicine, they're going to get sick again. And some of the factors that come out have really been fascinating. So for some people, hitting a 4 p.m. appointment, 4 p.m. in the afternoon appointment, can be really difficult, for whatever reason. And being able to find that out, it sounds simple, but oftentimes, if you're looking at a list of 500 patients, finding those little details can be really tricky, and we can apply ML to do that. Similarly, if someone doesn't have transportation, that's a big reason for visit non-compliance. Or if they have dementia and they don't remember things very well, that's a huge reason for not taking their medicine. And so we will amass say 150 different features per each one of these predictions in order to really tease out at a super detailed level what is going to drive this prediction risk that we have. This is the Health Promotion Board in Singapore. So Singapore has a population of around 4.5 million people. It's one of the most affluent societies in the world. It's super hot out. So it's really hard to exercise. And culturally, it's not a society which traditionally has really valued physical activity. It's one which has valued mental acuity, studying intelligence. And so as a result, they have tons of money. There's not a ton to do in Singapore except to shop and eat and drink. And so there is a big problem with obesity and then with diabetes. And the government projections are that diabetes will become a national security threat within the country. So they're being very proactive in terms of addressing this very early on. There are 3 programs that they're using to try and get people to be more active or live a more healthy lifestyle. The first of those is called the National Step Challenge, where they've given around 1 million people wearables, and they're tracking the steps for 1 million people. They have prizes, awards, recognition for participants in that program. The second is called Eat, Drink, Shop Healthy, where there's an app on your phone. When you go to a grocery store and you buy, let's say, bananas, you can scan that, and that counts as a healthy food. So you'll get points for that. And then the third is called LTPA, Leisure Time Physical Activities, where all around the country there are places you can go to do yoga or Pilates or Tai Chi or whatever, and you scan and you get points for that. So they've engaged KenSci, one, just to do the variation analytics to understand who's participating, men, women, age groups, which days, etc., but also to drive upselling, meaning try and get people to, say, move from 5,000 steps to 8,000 steps, or to get strong steppers to do more LTPA, more leisure time physical activities. So now we're working on a program to provide nudges, meaning, hey, great job with your 5,000 steps. If you take 7,000 steps, you'll be eligible to get a free beer. Maybe not that one, but so that's really fascinating. If you think about countries where you could do something like this, Singapore certainly is at the top of the list, right? Because 1, it's a small country. 2, the government is absolutely pervasive there. And 3, the people are fairly docile when it comes to government management of their information.
I don't know if anybody else saw Crazy Rich Asians, but apparently the whole thing was a lie. Because they were all these skinny, fit, beautiful people who were always outside.
Well, you know what? So, no, that part's true. And so I was with my wife, and we'd been in Singapore a year and a half by then, and she's Singaporean, right? So she knows the country really well. And for me, it was so cool to be there and understand much more about, where she'd grown up, spend time with the family, et cetera. So we went to Raffles, which is a super famous hotel, to get dim sum there. And there was a table of these gorgeous Asians, right? So 3 couples, but I mean, the men and women were just big and fit and beautiful, and they were super wealthy. And when you walk around and you go to the hawker centers, which is where everyone gets, the super delicious but also not very nutritious meals, you see the obesity there. And very clearly you see the relationship between affluence and fitness, affluence and health. And that relationship holds true anywhere you go in the world. And it's certainly true in the U.S. Yep. Okay, and then finally Beaumont. So Beaumont, this is a really interesting one. Beaumont is a military hospital in Michigan. And they've engaged us to do this RX variation, to understand where they're using drugs efficiently or inefficiently. And this has been an incredibly frustrating project for me because the data has been really complicated. So the data from the customer is super sketchy. We have a new guy working on data for using Databricks, and the guy seems to make mistakes all the time. So the data will just change, and I have no idea why. And then finally, for me, to understand the data itself was a big jump for me because it's pretty complicated data. So the main table that we're looking at is called the med admin event. So that's actually getting a patient to consume. Are you in medicine?
No, I've just been in hospitals, but
Okay. So med admin event is when someone takes a pill or ingests a drug. Then there's the med order event. So there's a many-to-one relationship between admin, many, and order one. But then we also have another dimension table, which is encounter. So when do they come in? How long do they stay for? When do they go out? What's the primary reason they're in? Then there's the person table, the patient table, man, woman, age, primary care physician, history, etc. And understanding, I really ended up kind of getting confused between what was a fact table and what was a dimension table, because they really started to blend together. Because each table was itself so important, and I could gain so much, but I also had to keep sight of what was the real thing we were working on, and that was the cost of the drugs that are administered, not ordered, but administered. And I've done now 2 different redesigns of my data model as I've come to understand the data better. And so on the one hand, I've kind of felt like a moron, but on the other hand, I've also realized that I've learned a ton in this process, just about what this data meant. And it emphasized to me how I'm pretty good at data. I'm nothing like Brian, but I'm pretty good. But how much I can still learn here, and how much value I still can gain and then deliver back to people.
Yes. So for all your cases, they're all custom, right? It's not like you're bringing a product, but you're bringing techniques that you've developed, but it's custom for each of you.
This is a great point, because we wish to scale, right? So we can only scale if we're delivering a product.
Yes.
Right? We can't scale if we're delivering a custom solution each time. And it's this struggle that startups go through is, one, we just need to get a customer, right? And then we need to get another customer. And so we'll do anything to get those customers. But if we want to get our next round, they're not going to pay for more customer acquisition. They're going to pay for delivering a product consistently and repeatedly and with less and less effort over time. And so that's one of the reasons why I'd mentioned we'd taken what was a very broad portfolio and really tried to narrow it down. That's going to help us become more repeatable. Second is getting sterner with our customers. And when they want a one-off, then we have to say, listen, we're going to deliver you the standard length of stay ROR solution. Whatever you want beyond that, we will provide to you as a services contract. And getting that internal discipline is really tough. It's something at the moment we're grappling with. And being able to then translate this engineering imperative to sales and marketing people is also really tough, right? Because the sales and marketing people can still be in the mode like, oh, I've just got to sell. One, because I got to hit quota, but 2, we just need more revenue and more customers. And so there's this discipline element that gets involved. And it leads to kind of this evolution of culture within the company. And we have to trust on the engineer, and now I'm thinking of myself as an engineer, on the engineering side, we have to trust that the salespeople have the best interest in mind for the company. Even if they're selling stuff that we don't want them to be selling, we have to have that faith. Similarly, when we say to a salesperson, no, we're not going to do this for your customer for free, it's not part of our product, they have to have faith that we have a vision that's just as valid, just as important as theirs. And going from Microsoft to this tiny little company, all these things are just so much sharper than they were in Microsoft. At Microsoft, there was padding, but KenSci just feels like every decision is important and has ramifications, and that's been really exciting for me to experience. So this is just we've got a couple of awards. We partnered very closely with Microsoft, and part of the reason why is so many of us come from Microsoft. So Samir, the CEO, was on the Azure team very right from the beginning. So he worked directly for Joseph Soros. The CTO is a UW professor, but his wife works in Microsoft research, et cetera. So the ties are very close. We go to market a lot with Microsoft people. And in part, this is also something very interesting. There aren't many companies who are able to deliver an Azure consuming solution for Microsoft. And Microsoft really values that. Because, of course, Microsoft now is all about Azure consumption. So if we have the promise to, on a broad level, deliver lots of Azure consumption to them, it's been a tremendous lever for KenSci to gain support from Microsoft. That's just a hint. And then, we were mentioned in this view, KenSci right there. So there's some big companies here, and KenSci is a tiny, 75-person company right now, but we are starting to get real notice in the marketplace. And I think it comes back to the first thing that I observed about KenSci, which was the intensity of collaboration required between all the different groups. It ends up producing something that is noteworthy.
You work with Health Catalyst a lot.
You do.
No, you do.
We compete with Health Catalyst.
Oh,
yeah.
you do.
Yeah. And I'm currently trying to poach one of their analysts.
Yeah, I worked alongside them. It's a different way of thinking about things.
Any questions? Yes.
I'm curious if you've run into any barriers or resistance in the client organizations you work with towards adopting a more data-driven approach. I'll just leave it at that.
Yes, tons, for sure. We always find a champion. Right? It's always a champion who recognizes the need to make transformation and sees in KenSci the ability to make that change. And then with that champion, we're able to go in and work very hard to win over skeptics. And so right now, we have a big hospital system in the Midwest. We have 3 people on site all the time. We hired one guy just to be on site there. And he sits, so that this is where we've implemented the length of stay, risk of readmission solution. And so each day he's sitting in the nursing meeting and they're reviewing the list of patients. And so say, Bob is going to be let out in 3 days. And they'll have conversations about whether this prediction is correct or not and why the nurse attending thinks it's not correct. And the amount of learning that we're picking up from that is incredible, right? And so the goal is how quickly can we make this product really usable for this customer before they say, oh, it's just too much work. And so it kind of feels like this race against time. They want to use it. There are barriers right now because it's the first time we've ever really deployed it. So how quickly can we iterate on it? Any other questions? Yes.
Sorry. Were you picking up extra information from those conversations to figure out if they're bringing up points that should be included in your model?
Yeah, absolutely. Yeah, totally. So one of them, a big one was, we just decided. It was how many times in the past 6 months have they been in? And that's a feature that we use for predictions, but it wasn't something that we thought was so important that it should be up in our table of patients. And they said, no, for us, this is something we'll always want to find out because it just helps shape the way we think about this individual in particular. And that comes from being able to hear their feedback absolutely directly. Yep.
Must be very challenging to manage scope creep.
Oh yeah.
It seems like in every one of these meetings that there will be some opportunity, some other variable to consider.
And that's where the tension comes in too, right? Because we have a guy that a process guy that we hired from Amazon, who's Amazon's a different animal than Microsoft. So the Amazon guy is bringing in this type of discipline that we've never had before. And what he's saying is, if we're going to go live with this customer on June 10th, then we need to have a 10-day lock where nothing fails, nothing goes down, and we don't change the product. And meanwhile, we're having this prep every day with the customer. We're constantly getting suggestions and constantly trying to make sure the data is flowing in correctly. We're getting all the data drops right. And meanwhile, this guy said, no, we need 10 days before we can go live and certify this. And this tension is really an incredible thing to observe.
So you mentioned you currently deploy into your customers Azure tenants. So are you finding that there's a fair number of people already using Azure, or are you running into a lot of people know they're on AWS or they're on another platform, or they're not even in the cloud at all?
My sense is that Azure really has a stronghold in healthcare, and that's not documented by any facts, but we're only working with people in Azure.
Who are already established.
Yeah, I mean, it may be very young, but yeah, we've not gone in and set up an Azure instance for someone, just but all our IP is built on Azure right now. And so we can't afford to retool for AWS, for example.
In terms of product, do you when you update code, do multiple tenants get updated, or is each one kind of an update that you manage?
Right now we have 4 live customers right now, so each one we're doing individually. Of course, to scale, we would need to do this broadly, which is why we want to move people. We want to move out of customer Azure environments and into ours, which would make that much easier.
How long does a typical deployment take?
A lot of it depends
Maybe
on
the wrong concept of deployment, because it sounds like it goes on after the initial delivery.
Yeah, so right now, by 6 months, we want to be actively giving them predictions. And it sounds like a long time, but a lot of it can be just getting data. And so we'll send out a data contract, which says, we need, out of 200 possible columns, 100 we absolutely need. 50, make it much stronger. Another last 50 are good to have. And a lot of times, they may not even know how to go about getting that data, which means we'll need to send an engineer on site to work with it. And so that can really stretch out a deployment. Similarly, there's one customer we've been asking for, they want a length of stay prediction for pediatrics, but they won't give us the age of the kids. and so concerns around PHI are as they should be. They're incredibly high, but at the same time, there needs to be a level of reality too. That we can't do this unless we get this very basic.
I found that to be very, very much variable among healthcare clients.
Yeah.
It's subject to interpretation.
Yeah.
And prior lawsuits.
Oh, none yet for us. All right, so let me go into some demos. Okay, so this is something I started out just doing for fun. It's not fun. This is something I did out of interest. So this data comes from the Center for Disease Control, CDC, and they have great data sets. So if you're ever looking for a data set just to learn from, go there. So this data is, again, it's a horrible topic. It is drug-related deaths. And it goes from 1999 through 2016 at the county level. So it's pretty granular. And I have two basic measures that I'm looking at. So one is, what is the mortality rate per 100,000 of population? And the data comes in, and the table has county, year, population, so total population, and then mortality rate buckets, going from 0 to 2, 2 to 4, 4 to 6, all the way up to greater than 30. So in order to be able to calculate fatalities, which is that 597 number there, I convert the bucket into an average, just the middle of the bucket, right? So 2 to 4 becomes 3, 4 to 6 becomes 5, greater than 30 I called 31, which leads to an interesting result, because 31 is not the real number in the counties where opioid use is worst. That rate can be as high as 80. And so I'm vastly understating this number. But what you see here is that the mortality rate almost triples, going from 6 to 17. Fatalities move in exactly the same way, from 17 to 55. And then it varies pretty sharply by region. So who has a guess about which region of these 6 that I've created has the highest rate, mortality rate?
Southeast.
Southeast, right? That's what I thought. So we select the Southeast, and actually it's right here. So Southeast has 17 point, what? 17, that's like, so 11.5 is the average across all the years. But in fact, the Southwest is higher. Southwest is 12.2. And when we go in to the Southwest, the state that was the worst, anyone have a guess on the state?
California.
We're talking mortality rate, not number of deaths. New Mexico, who said that? It's New Mexico, right there. Whoop. So New Mexico is 26.9. This pop-up chart has 2 measures. One is the average mortality rate across these 18 years. The red line is the mortality rate in 2016. So what is this telling us about the counties in New Mexico?
Don't move to New Mexico.
What it's saying is more than half the counties are at this highest threshold.
So have you correlated that with things like income?
So yeah, in the next page, so we drill through to the straight page.
Sampling error, because you have such a small count in those small states compared to the others.
I haven't researched that. I think the CDC really works hard to validate these numbers as much as possible. But you're right, the sampling size is much smaller than in bigger cities, for sure. But yeah, so here I did integrate data from the census, so income per capita, poverty rate, how they voted, women-owned firms, etc. And then I need to move over to New Mexico. So in New Mexico, it started in this county, Rio Arriba County. And I'll show you that when I come to the Choropleth map. So this is the map box Map, have you guys used this at all? I love this map. I just think this map is awesome. So in 1999, there are 2 counties where mortality rate is the highest. Rio Arriba County in New Mexico and McDowell County in West Virginia. So right there. So these are the 2 average centers. So the people who said southeast, you also were pretty much right on. So now I'm just going to click through the years and watch what happens over time. So the height of the column indicates where fatalities are the highest. So California, Los Angeles County jumps out just because it's such a populous county. But now we're just going to click through years. So 2000, 1, 2. And you can see it's going to start to accelerate right there. I was sitting at home. I first did this at home. And I was in my office at home. And my kids like to come in and sometimes see what I'm doing. And I shut the door and I wouldn't let them in because this scared the shit out of me. Right? I mean, think about the difference across time, what's happened. And then think back, to people we know, things you read in the newspaper, how bad this problem is. And a really interesting article in the New York Times was just a couple of days ago, how heroin is disappearing off the streets in many cities, particularly in the East. But deaths haven't fallen. It's been replaced by fentanyl, right? And fentanyl will kill you much faster than heroin ever.
Add the time series slicer.
I don't think Netbox has one. The
No,
RJS
no,
one.
you just replace your
with the slicer, yeah.
with the time series
Yeah.
with the play axis.
So then I became intrigued by those counties where they hit the highest rate. So what we have here, this line is the number of counties where the mortality rate is greater than 30 deaths per 100,000. So you can see in 1999 there were none. In 2001 the first 2 appeared, New Mexico, West Virginia. 2005 there were 4. 2010 there were 30. 2015 148, 192 in 2016. So we changed the axis, y-axis, to log. Where is it? Linear to log, and we get a straight line. Right? A straight line. So I did a projection, I did a forecast. Let me unselect here. So first, and this was just remember I'm an Excel guy, I'm a finance guy, so this is an Excel-based forecast. But this was I started out in 2012 just to see if I could get something pretty close, and this was all right. So then in my real forecast, when I extend it out to 2025, we get up to 1,758 counties out of the 3,049 in the United States. So well more than half the counties in the United States are at this supersaturation point. And this has been, this is a pretty simple demo. There's no ML in this, but there is a moving story in this. And this is now a pretty standard demo within the Microsoft Health Group. I've given them this and they use it a lot because they can get to people in government really easily with this. And in fact, at the Microsoft Government Forum that's held in DC, one of the last things I did as an FT was presented this, and the Secretary of Health and Human Services for the state of Virginia was at me right after saying, I need this, I need to be able to show this. Because they're just desperate to be able to illustrate the impact of what's going on here. Okay, so this is a pretty basic demo. Let me move to the first thing that we actually went live with at KenSci. So this is an ED operations board. It's predicting arrivals and census in the emergency department. So we were getting 15-minute dumps of data from the emergency department. We were running models on it and then spinning models immediately back out. So every 15 minutes we were updating our predictions. So you see the timestamp here. This was March 28th, a year ago at 10 a.m. We would have had a 10:15 mark and numbers would have changed to reflect that. But here we're showing the census is a snapshot in time. How many people at 12 p.m., the current time, were actually in? What is going to change over time? Below that is arrivals. So this is what is taking place across an hour of time. So you have to think about the data a little bit differently. And then the last one was arrivals by acuity. And this ended up being really, really powerful because what we learned is that acuity levels really were what drove staffing demand. right? Someone coming in with a, cut open chest needs immediate attention. Someone coming in with a sprained ankle can wait. And as we progressed with a customer, acuity levels became much more of a valuable determinant of staffing. It was also really interesting thinking about how we use this with the customer. So the nurses in the ED really liked it because they could gain comfort that they could be staffed to meet demand, because their concern was to not have enough people on hand to meet all customer demands. But the people that were paying our bill were the finance people, right? The administration people. And their concern was overstaffing. Where were they being inefficient staffing? And this did very little to address that. So then the next thing we built was the staffing demand, which was right here.
Real quick on that, like say arrivals.
Yeah.
Like what kind of data points are driving those predictions? I mean, you're looking at past stuff, but it's like what kind of features are involved there? Is it like, well, it was a full moon on a Thursday, and typically that drives
We rejected the full moon request. No, but it was a real request. There was a real request. They requested, could we have data about phases of the moon? Because nurses there believed that it did.
Yeah. Oh, and nurses have a lot of kind of mythical beliefs about things that may be right or wrong.
So time of day, day of year, weather was a big one. Number of patients. We would get data on the patients who were currently in, and that might inform us about who else might be coming in. So let's say construction workers started coming in. That might be an indication of more construction workers coming in, or athletes, student athletes, might be an indication of a lot of sport games that day. Holidays became a big one. What we didn't get to, but what we wanted to do was Google searches for emergency departments, and that would have sent our accuracy right to the roof. And it's kind of embarrassing when you think about that from the start. But that was the next thing we were going to do here. So then we went to the staffing. And so the staffing, what this showed was this is just looking at demand and capacity. And so what you see here very clearly is that they were way overstaffed according to demand. So the next thing I did was, sorry, let me come back. Max shift capacity. Yeah, so nursing demand and max shift capacity. So then I did census, where I was looking at what's the average census and the shift capacity. So this is getting a little closer, right? Here we can see some points where maybe the census is exceeding the capacity, and right here it actually does, but many points where there's a ton of gray.
What's the definition of census?
Census is how many are in at a snapshot, at a point in time. And then this one was combining predictions with census with staffing demand. And this one was really powerful because what it said was, hey, our predictions are really pretty good, right? They're aligning really closely with the actual census. And then that gave them confidence to start to say, hey, can we reduce this baseline level that we program in? And when can we reduce the top level?
These predictions are not happening in Power BI. You're doing like in Azure ML services or Databricks or outside.
Yes, yeah, that's absolutely correct. And then it was streamed into Power BI. Well, no, it wasn't streamed. It was dropped every 15 minutes in Power BI. So we had 15-minute refreshes. Okay. Any other questions on this? All right. So now, okay. So then this is what we did for Kaiser. So here we have list of patients in. This was just demo material, so only synthetic data. But we had what was the risk of readmission, what was the ejection fraction. So ejection fraction is a measure of how efficiently your heart is pumping blood, and a score of less than 50% is a very strong predictor for a heart attack. We had risk of mortality, visit noncompliance, and RX noncompliance. So we could sort or filter by these different patients. We could mouse over a patient, and let me find this guy. See what their predictions were and the reasons for those predictions, just with a mouse over. And then we could drill through and find that patient. And then get detail on that patient. So this was pretty basic data about who they were. But then we had what is the predicted risk, what are the risk factors, and then what could they do in order to adjust their risk. So what control could they exert in order to bring down their adjusted risk? And let me hope that works. Yeah, right. So the point here was that clinicians wanted to be able to sit with patients and impress upon them the amount of influence they could exert on their own health outcomes.
So what's going on when you click on the filters there for is it the
ROR?
Is it rerunning the model or what's?
No, in the back end, we just assign an impact value for, say, complying, visit non-compliance. We said that has a 5-point impact. Yeah. And this is in fact a little simplified because all these factors are kind of interrelated. So choosing 2 out of 3 would have a different impact than choosing another 2 out of 3. So the goal was, in the end, how do we really think through this? And the solution was we couldn't get all the different permutations in a table. We would have to actually do live calcs, and we've not yet progressed to that point.
It is a good demo,
It is a good demo. Yeah.
Are you connecting to machine learning models behind it?
We're connecting to output from ML models. So right now we're using Databricks. So we're getting output. Those get brought in. Right now I'm just connecting to Databricks tables to drive my Power BI files.
Which libraries, packages are you using, like AutoML, or what in Databricks?
You know what? I don't know. I'm sorry. I'm a finance guy. And no, I'm learning, but yeah, seriously. Right now I'm just trying to get anything I can from the data scientists. But if you want, I can have them follow up. Okay. So this was really well received, but it was interesting because we presented this to doctors, to nurses, and to care schedulers, and all of them wanted different versions. Right? And they said, this is a great start, but it doesn't do it for me, and it doesn't do it for her, and it doesn't do it for her, and what she needs is not what she needs, and it's not what I need. And this was, for me, another kind of real jump in terms of recognizing the need to understand the customer's requirements at a really, really granular level, and having to put yourself in the place of the customer and really work hard to understand them. That's why we hired so many doctors and nurses on our staff, is because their understanding is much more than I'll ever have, and we absolutely need that to be successful. All right, so I want to move on to another demo. Okay, so first we'll take a look at the KenSci platform. So this is, we split up into KenSci IO and KenSci.ai. IO is really the platform piece, and these are different things we're building out, but I'm going to show you the model bank. So when we click into the model bank, these are our ML models that we've worked on, and you can see we're covering a wide variety of things. This kind of predates our narrowed focus, but we have run predictions on all of these things. So we can scroll down and pick this one, risk of 30-day readmission. When I click into this, we have model name, who the author was, a description of the model, the academic references that were used in production of the model, and we do this for every model, and we work very hard to publish papers with our customers. And in large part because one of our founders is a UW professor, so he brings a very academic focus to this, and that means a belief that we need to reference our work on real science, and 2, that we need to be an open book when it comes to our ML. And so we make all our code available to our customers, and they can work right alongside with us to see that code. And if you say IBM would never reveal what Watson is doing. But for us, it's a core tenet that people see our code and understand what it is.
This is a custom-built app. It's not using some any Azure services at all.
No, but what I'm going to so this one is not. I have a demo here where I'm going to show you where I used ML, and so I really do this. This is my one claim to data science, is that I used ML, this Machine Learning Studio to do an experiment. So at any rate, the risk of readmission models here. This is the accuracy numbers, etc. You can go out to GitHub, and that's where you'll see the code. Okay, and then we'll come back, and then you can go into a different model. So then we're going to come to KenSci.ai, And this is where we would put work around where people can come in and see things. So this is not Power BI. This was written by in TypeScript, where they write all these visualizations. So we're doing Power BI or this. But this is where customers would come in order to see different model outputs. So this is embedded Power BI. So now let me come to my main demo. So here's my main demo. This is Bill Johnson. I spent a lot of time finding that photo, by the way. So I'm gonna run Bill out and tell you Bill's story. So Bill, like many Americans, didn't really pay a ton of attention to his health until right here when he had chest pains. And so he went to see his doctor. His doctor said, you know, Bill, time for you to stop smoking, exercise more, better diet, etc. But Bill just pretty much ignored him. But he went on until he had this very severe event where he went into the hospital by ambulance. He spent 7 days in the hospital, treated for a heart attack. He was let out, but then had a 21-day readmission. Let out again, followed by a 3-day readmission, and then finally out for a while, for a year, until he went in with another heart attack, or chest pain scare, let back out, then finally back in for another lengthy stay in the hospital, and then shortly after, Bill passed away. And so Bill's health trajectory was really damaged by these readmissions here. And it began by the fact that he went on too long before he took active steps to prevent his health from deteriorating in the first place. And so the goal is to use measurements like ejection fraction to identify people who are at risk well before they have a heart attack, so 3 years before they have a heart attack, and get them to change their behavior in order to change outcomes. And so this length of stay risk of readmission outcome is really important. And so what I'm going to show you is, I don't think I'll build it in front of you, but this is my model. And I took a data set which was about 80,000 rows, and we were there to predict the risk of readmission. So the prediction column is risk of readmission, high risk or no. It's different information about the patients. And then I use a 2-class boosted decision tree to drive the model. We evaluate the model, and it turns out to be a fairly accurate model right there, and then we see 0.955 accuracy. So a fairly accurate model. So then this is now me returning to my roots as an Excel guy, and I say, hey, let me show you how this thing works. So I'm going to use some sample data. It's going to give me, I didn't want it there. Hang on. Give me some sample data. Let me use this data, and I'm going to run this prediction. So it takes this 5 rows of data, it sends it up, and it comes back with scored labels and scored probability. So 1 would be, yes, this patient is at high risk of readmission. That's kind of cool, but it's also kind of fake, right? Because I'm using this 5 rows that came from the original data set. But here I have 5,037 new rows of data. So I highlight this, and this is going to be, that would have been a mistake. Okay, so this is going to be my new input data. Okay, and now I'm going to run the prediction. When we come back here, it's going to bring us back those 5,000 rows of new patients, but with scored probabilities. And the point here is that an analyst, a finance guy, can now engage very proactively with clinicians doing data science. And so this is one of the things that I kind of have this fervor about enabling with our customers, is to say, hey, let's not just keep it at the data scientist level at our hospital customers. Let's also enable their analysts to do this type of stuff. So can we build tools that enable analysts to really start to do this stuff? So now we have these 5,000 rows in the medium that I'm really comfortable with, Excel. So I could run a bunch of analytics here, but I also can use it in Power BI. So then we come back up to Power BI. Now we have the same data set, but I can take a look at it in Power BI. Things look really slow. Okay, so what we're going to see is 5,000 patients, 25.7% risk of readmission for this entire population of patients. So this is 1 week's worth of patients being ingested into a Midwest hospital system. And I wanted to build this, so we did this for a couple of reasons, but one was just to show, say, high-level CEO, CMO inside of a hospital, what they could see from an analytics perspective. So here we're looking at, we can cut it by hospital group. So in this case, we'll go down to the Gulf states in Texas, or let's go down to the Gulf in Texas and see this hospital group and see that they have a slightly lower risk of readmission than the overall number, 25.3. Or we can switch to another important dimension, which is diagnostic category. So in this case, major organs and systems. And with major organs and systems, there's a higher risk of readmission, 28.3%. So we may want to focus on major organs and systems patients coming into the hospitals, 20.7%. So when I come to the cost mitigation page, this is where I could sit with a decision maker, say the CFO, and finance guy to finance guy, say, hey, listen, your return, your ROI on putting together a risk of readmission solution could be worth your effort. So out of 1,500 major organ systems patients, 436 are at risk of readmission. That's a 28.7 rate. At 11 grand per readmission, you're talking about 4.7 million just for this 1 week's worth of patients, this one diagnostic category. So Medicare has set guidelines saying that we should be able to, in almost every instance, reduce the readmission rate by 50%. So this would bring us down to 14%. So we run the slider down to 14%. Let's get 15. Good enough. And it's going to show around $2 million in savings by cutting it in half. So 2.26. The top end of the scale should be at getting it 2/3. And this would put us at saving $3 million just on 1 week's worth of patients. So what I found, this is from when I was on the CAT team, is that people love to be able to play with stuff. And this type of slider really gets them engaged because they feel like they can exert some control over what they're working on. But then the next thing was to sit with clinicians and help them identify the high-risk patients. So now we have the 1,473 major organs and systems patients. How can we narrow this list? One of the biggest challenges for healthcare providers is to figure out where do they allocate their time. And so we would say, who are the high-risk patients for low ejection fraction and for risk of readmission? So when I select them, we filter down to just 43. Okay, and so when we get to 43, that's a much more manageable group of patients than the original 436 that we were thinking about. So now I may want to do something like what I'd shown before, which would be go to the patient drill down page and set up a interactive visualization where we can sit with a patient and be able to lower their risk score. So I've shown you that in the other one. I won't show you that here, but it's essentially the very same page. Or this embedded Power App right here, where let's say we want to select patients to focus on. Come on. Okay, so if what is going on? Okay, so I'm going to select these two patients. This is an embedded Power App, and so then I'll click here. I have two options. The first would be to send a PDF out to OneDrive. These are both. This is HIPAA compliant. OneDrive is. So when I send this PDF, it will appear in my OneDrive, and I can disseminate it out to people who want to use this information. So I click right there. We'll see the OneDrive come up. Okay, so there are the two patients. Or coming back, I can send an email. In this instance, I'm sending the email to myself, but it could be sending an email to whoever would need to get it. And this is a really simple example, but it's an area that I'm really interested in figuring out how can we exploit to its fullest for KenSci is giving people real actions they can take in order to speed the workflow up. And make data science not just something that you consume, but something that you take action on. So that's it. Thank you.
So maybe any questions for Jeff? We can do a few questions. I know we're running late, but.
Have you guys been exploring the new AI workloads that are in Power BI and how it kind of goes to Azure?
So no, and I'm pissed off about it. So, so I went to Mark Regera, my old boss, and he and I were really good friends. I said, Mark, have Justina put me on. So Justina is the gal that's running it. And he said, Justina's really busy. It's in the middle. It's too late. And so that's where I am with Mark. But I'm going to go back to it.
Okay, Brian and I have been digging deep into it.
Really?
If you want to talk, we can.
Oh yeah. So you find it really useful?
It's kind of buggy. It's first version, but it's pretty powerful. And I think for sharing, kind of like with that add-in in Excel, you're giving it out to Excel clients. It seems like you can have deploy models that then become like custom functions in data flows for transformation. It just builds right into the API of your deployed model. So it's a pretty cool layer of deployment.
Yeah, I'd love to hear more about it.
Okay.
Thanks.
Cool.
When I saw one of your early on videos, I think it was like the Power BI University 101 when you're at KenSci, but I remember you said that one of the biggest things that you focused on when you were learning Power BI was modeling, the modeling part of it. And you get the modeling down, everything else becomes a little bit easier. But as you started going into the machine learning and AI, what's kind of your cornerstone where you're going to look to focus first? You get this, you understand these concepts, things become a little bit easier. Was there anything like that, or is it still kind of?
I'm still too stupid to. I'm working. I'm right now focused so much on delivering Power BI analytics that are useful. Meaning taking the output from the data scientists and then making that useful. That I haven't had time to really try and learn data science. And to be honest, I just may not just learn.
What connection type are you using after the data comes out of Databricks? Are you using Spark connectivity, or are you?
I'm using the Spark connector on Power BI. We're reevaluating that because it seems really slow.
Yeah.
And there was an interesting comment about strings adding in memory. So I first got a model for the Beaumont RX variation, and they were using really long text strings to identify patients, doctors, drugs, admin events, etc. And it was killing memory. And there's a gig limit on embedding Power BI files, and we were running at 2 gigs.
Okay.
And so I made them take those out and put in numeric keys, which brought us down into the limit. But then, in order for them to take action on what we provided, we needed to restore the original keys, which means I was bringing in by direct query those keys, and then again just fuck performance.
Okay.
So we're thinking maybe we need to go back to an Azure SQL DB first.
What?
An Azure SQL DB.
Okay. Yeah. Cool.
What is the visual used in the patient field analysis? And the one you press play for? And
it's a simple bubble. Series? It's a bubble chart. It's a bubble chart, and then I layered in these pictures.
The play?
This built into the bubble chart is a play access.
Oh, okay.
Yeah, as long as you put a date or a number series on the, I think it's a play axis. There's actually a field one called play.
I did this once with there's this great website that tracks airplane sales to different airlines, and it goes back 20 years. So I went back even for 25 years. So I went and I got all the history for Boeing and Airbus and Embraer, and I got to sit in front of some Boeing guys and I showed them this data and showed them how 737 sales and then A320 sales, how they interacted, and it just made them crazy. It was really fun.
Let's not imagine what that might look like in the next year. So.
Right. But this was really useful for that because it was like a race. And then who else? So Regera did this with soccer.
Yeah.
With the Spanish soccer teams, Real Madrid and Barcelona. He did the same thing with points.
Cool. Any other questions? All right, Ron.
We've done it again.
And,